Oh, there we go. Beautiful. All right. Let me know if y'all can hear me, and then we should get started. All right. Cool. All right. So let's talk about routing today. All right. So what are routings? Um, so when we're talking about Node.js, and uh, are people getting an error, Alex? Are you getting? Try to refresh, I suppose. It was giving me an error earlier. It was like a bad stream key, so I updated it. So it should be fine, but let me know if you're getting problems. Um, Everything looks green on my end, so yeah, let me know if you're still having problems. Um, all right, so something that we call endpoints. So with Node.js, you're getting an error too. Interesting. Uh, each verify yourself. Okay, good. All right, yeah. So when we're talking about endpoints and stuff, we're usually talking about some kind of like resource URL that basically allows us to either basically allows us to interact with resources. Okay, I'm saying resources because I don't want to say like something very particular like a file or anything, because it's really, that part really is meaningless. All you have to understand is that the endpoints that we interact with is basically going to help us um, you know interact with possible data that lives in the backend, whether that's in a database or some file or something, or maybe it's an API that is a proxy that gets data from somewhere else and serves it to you. That's totally a valid scenario. Okay, so resource URLs look like this. Okay, it's everything that happens after the slash. So slash media is, could mean something, right? Be like, oh, that's the media. Slash media slash photos gets you, you know, we're talking about photos under the media noun, okay? And so we have the situation where we can have identical URLs with different HTTP verbs, okay? Those are separate endpoints. So get slash media would be different from post slash media, okay? So for example, here, this is pulled from Instagram's API docs. I'm sure it's different now, but this was back in the day, like 2 years ago. So this is the protocol. It's under HTTPS. This is the domain, api.instagram.com. And then this we can say is the resource, or the URI, the universal resource identifier. Sometimes we call them URLs. Just know that this is just called the resource. So the resource here is version1 slash self slash media slash recent. And we're looking at the recent. This is the resource we want. That's from media, that's from self, that's from version1. This stuff right here is all made up. Okay, this is all depends on how you want to call things and how you want to structure them. So none of this is standardized. This is all made up. Instagram uses this, that's fine. Twitter uses something else. Facebook uses something else. Everybody uses something else. Okay. And then anything that we see, like every time you see a question mark, that's the beginning of something that we call query parameters. So just like you set up a query with SQL, you can add parameters to your query, right? Essentially, when we access some kind of endpoint like this, we're usually asking, usually a question. We're constructing a query, if you think about it. We're like, can we get this? I would like to start a query. Can we get this? Or, hey, I would like to start a query and can I send you this information, like this file, this image, something like that. Okay. And so what you have then is tuples, key value pairs of query parameters. So in this example, we have one query parameter, and the key is called access underscore token. Again, this is for Instagram, but you can make up your own. And then you set up the value using an equal sign, okay? And if you want to have more than one query parameter for whatever reason, you can append more by using the ampersand. Okay, that's if you use Shift 7. So it's like that weird squiggle thingy on your keyboard on number 7. And that's an ampersand. Okay. So endpoints may accept data. That's possible. When you're trying to do a search, some kind of query, you can send some JSON, some XML. Again, it's really all depends on how you're going to architect your backend. I'm being very vague because there is no like right way. It all depends on your scenario. So let's talk about, what's a like a RESTful API. And I am getting an error too. Let's see if I refresh. Okay, I got an error from YouTube. I don't know what's going on. Okay, so something that's going to be probably asked of you a lot when you're trying to interview for, like, let's say a backend position, because remember, this is very much backend heavy. But also if you're front end, so basically anything with like web, any kind of web stack, whether front end or back end, if you're interviewing for a job, they're always going to ask you these questions like, what's a RESTful API, right? And so I'm going to give you that answer right now. So what is a RESTful API? So let's talk about that. So RESTful, okay, stands for, at least the REST part, stands for representational state transfer, okay? And what we mean by this is we're talking about resources, okay? And resources can be anything. It can be a file, it can be another URL, or it can be data from like a database, like a person's profile, like from Facebook or Instagram or insert whatever social media, okay? That's why we call it a resource. It's very vague because that part doesn't matter. So a resource, again, is any object an API can provide, like a photo, a song, more data, a URL, anything really. And the server responds with something that we say is a representational state of the resource requested. It doesn't actually send you the actual data, it sends you what the data looks like, okay? It can then give you, more information about how you can either actually get the thing or how you can manipulate it further. And what we mean by that is what we're going to talk about later, which is the HEDUAS. So a representational state is usually in like JSON, but it can be in XML, or XHTML if you want to serve that. But it's usually between JSON and XML or some custom, data format. Again, at that point, it has nothing to do with the data type, because again, it's all just going to be a string and bytes. But how you lay out the data is going to be, dependent on how you want people to consume your API. The standard really nowadays is JSON. We don't deal with XML anymore as far as this type of scenario. And the reason for that is because XML is very verbose. There's just a lot of characters that's required in order to, structure the data. In JSON, there's a lot less characters that are required in order to structure, your data. And we're going to show an example of the two, and you'll see what I mean. So the constraints for a RESTful API are the following. It must have a uniform interface. It must have client and server separation, meaning you don't need one to have the other. They're completely separate. So the client doesn't really know much about the server, and the server doesn't care what's the client. So what we mean by that is that, anybody could consume your API. It could be a browser, it could be, just your laptop, serving like native API calls. It could be a mobile phone. Heck, it could be a satellite up in space. It doesn't matter, and it shouldn't care. It has to be stateless. So one of the popular transport layers that is used with RESTful APIs is HTTP, but you could technically use anything as long as you can communicate, doing requests and responses. The transport layer doesn't matter here. So Alex is asking, is it more common to see JSON over XML nowadays? Yes, it is, because it's cheaper. And we're going to see an example of that. But XML is still used heavily in certain, frameworks. So it's good to know both. Chances are, if you work at a company, they're still using XML in other areas of their application. It may not be on the website, but internally, it's pretty standard to store a lot of your configuration files in XML. Though that's probably changing, probably to JSON or just some other custom format. We have a lot of data storage now. It's not a big deal. So, it's more quote unquote human readable to store something in like JSON or XML versus just straight binary, because you need a hex editor to read it. And even then, it's just like, it looks all weird. All right, and then we have a layered system. So we're going to talk about that. Cacheable, your resources can be cacheable. And then we have this thing called code on demand. So we can stream code whenever we need it. So this is going to relay back to front end when we talk about code splitting. All right, so if you want to read more about RESTful constraints, there's this great Medium article. It's fantastic. A lot of information is pulled from there because I just love the way it's broken down. So I'm going to link that in the chat. If you want to take this stuff really seriously, you're going to have to start reading like a lot of articles, blogs, reading. There's a great book. I forgot what it's called. It's like the RESTful Cookbook or something. I'll find that book and I'll put it in the Discord chat. But it's a fantastic book. If you want to learn how to build like an actual, like, how it's supposed to be RESTful API, because a lot of people aren't using REST. They think they're using REST. They're using RESTful, which is kind of like REST, but it's not REST. That's why it's RESTful and not REST. Okay, so the constraints when we talk about uniform interface is the following. You have a unique and logical URIs. Okay, so no two URIs should be able to point to the same resource. That doesn't make any sense. And in fact, it's common sense, right? That we would agree on that. But we have to put these barriers in place as, for us developers, so that when we're building our infrastructure here, that we're not making mistakes. So for example, it'd be very weird if two file descriptors that are on your system pointed to the same file. They're usually completely separate files, right? So with your API, it's the same thing. If I say /people, right, that kind of means, oh, this API is going to return people. But then if I put /tuna, it also returns people. That doesn't make any sense, because, you know what I mean? Like, now we have two different ways to identify the same resource. Which is the one we're supposed to use? That can be kind of hard to keep track of. And so again, and the server is going to respond. Response must provide adequate information to the client to act upon. So when the client requests, hey, can I have this person's profile? The server is supposed to send all the information that is required for the client to understand the information. So for example, if you were like, using, let's say, Facebook APIs, and you get somebody's profile information, well, one of the keys that's going to be in the JSON is going to be something like their profile URL. So you can get their profile icon or whatever. Okay, that way you can get more information about them. It's not going to give you the actual image, but it's going to give you a link where you can actually get the image. So it's allowing the client to get more information, right? It's giving it more adequate information. Also, if you want to see this particular person's friends list, for example, it'll give you a link. It'll provide you a way to also access their friends. Okay, so it's giving you all this information so you can, um, act upon that resource. It's not. It's so again. It's very vague. Being very vague because I don't want to tell you something to be like it has to be this way because that's it. It's on a case by case basis. So each request contains all the information the server needs to respond as well. So if I say, hey, I would like to have this, I want to see this person's profile. It's just like, you need to tell a server, okay, which person? There's like a bazillion people. Which person do you want to actually see? And then let's say you tell a server, okay, I want to see this person, but you only wanted their first name. You didn't want the entire profile. The server doesn't know that, right? The server can't read your mind. So every request that you send, you have to give the server all the information that it needs in order to serve your resource the way that you intend to see it. The server can't read your mind. So that means that we're going to have to put things in place to tell the resource exactly what you want and how you want to see it. Because again, the server can't read your mind. And then likewise, the server responds with all the information the client needs to understand the response. So for example, the server responds and gives you the payload, but then what if they don't tell you what the payload actually is? What if they tell you it's plain text when it's actually XML? Okay, Apple's API actually has this problem. They'll serve you plain text when they actually give you JSON, and so that's a pain in the butt. I'll show you an example of that. I don't know why Apple does that, but whatever. And then we have this thing called a hypermedia as the engine of application state. And this bulletin point right here is what most companies don't abide by. Why? I don't know. But they don't do this. We're going to be talking about this a lot. I'm going to show you an example. So when we build a RESTful API using Express, your API is going to actually follow what REST is meant to look like. So we'll talk more about this. But this stands for HEDUOS. It's called the engine hypermedia as the engine of application state. So HATEOAS, HEDUOS. It's like this really weird acronym. Okay, and this is going to send information of how to modify the object states. And these are basically links. They're going to give you more links. Okay, and we're going to go over an example of this. This is very, very important. And another constraint is this client-server separation. So the client and the server, they act independently. So the server doesn't know who the client is, and the client doesn't really know who the server is. The server could be Windows, Linux, Mac, could be Raspberry Pi. The client shouldn't care. It's just like, here's the URI, give me this, and then that's it. The communication is going to be done using requests and responses. Again, we're not saying it's HTTP. Okay, that's not what we're saying. We're saying that as long as the communication has the ability to do requests and respond to those requests, we actually don't care what the transport layer is. It could be HTTP, it could be WebSockets, it could be some other type of peer-to-peer or whatever. It doesn't matter. As long as there's this messaging mechanism with request and response, that's all we need. Okay? And the server has to wait and listen for a client to initiate a request. It would be very weird if Facebook or YouTube was able to send to your browser pages without you asking it. That's very weird. So the server can never talk to a client until the client talks to the server. That's how communication is initiated. The client or the requester sends a request, then the server speaks to the client, not the other way around. The server should never talk to the client before the client does a request to the server. Okay, so hopefully that makes sense. And again, just like HTTP, what we talked about earlier, RESTful APIs, they have to be stateless. Okay, they're not going to keep track of, oh, you sent this resource, you did this resource request, and then when you do another resource request, it's not going to remember you. Okay, you can add mechanisms on top of that, right? Like cookies and tokens. We'll talk about JWT, the JavaScript Web Tokens. We'll talk about that. But the actual API itself, like how the resources work, should not and uh, should never keep track of the state explicitly. You can add mechanisms on top of it, but at the end of the day, the APIs should always be stateless. Okay. Each individual request contains all the necessary information the server needs to fulfill a response adequately. So that kind of rolls back to the first point, but that's also part of stateless, right? If you send a request, hey, can I have this person's profile? And then the server responds with the profile information. And then you send a request, hey, can I also have the friends? The server is going to respond with friends of who? Right? It doesn't know who you are, right? The communication had ended. The TCP connection broke after the response was fulfilled. So if you say, "Can I have this person's profile?" it will send that profile. And then you say, "Can I also have their friends list?" If you don't specify who you're talking about, the server doesn't know who you are. It doesn't know any context. It doesn't remember the last thing you requested. So you can't expect the server to know. Okay, that's what we mean by stateless. So every request that you send has to have all the information you need, regardless of whether or not you sent a request before. The server will not remember you. That's what we mean by stateless. And we have a layered system. So we have, each request may go through a series of layers. So you can have a security layer, like maybe like a firewall, or you're doing some kind of like authentication, stuff like that. You can have a caching layer. Oh, let's say it's a resource that is probably asked for a lot. Well, maybe use something like memcached or you're some kind of caching system. So instead of having to look up the resource, because that could be kind of expensive, we'll pull it from cache and send it back because this is like a resource that is asked for a lot. So you could do something like that. And load balancing. Oh, we have this API that's going to get hit by a billion people, thousands of times per second or whatever. Um, you can use a load balancer. That's an extra layer you can use in order for your API to still be able to serve all these resources, right? So, load balancing, that's more of a cloud, topic, but, you can use load balancers to do that. Again, that's just an extra layer. The client, basically the browser, your mobile phone, doesn't care about those layers. It's agnostic. The client's just, yo, can I have this resource? It doesn't know that it went through a security layer, a caching layer, a load balancer. It doesn't care. It's just like, yo, can I have this resource, please? Can I have, my profile pic? That's all I want, right? And the server should respond. It should not be like, oh, I'm gonna go through a security layer. And like, no, 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 no. The client is agnostic to all these layers, okay? And the layer should not interfere with the request response communication. So what we mean by it shouldn't interfere, let's say you do go through a load balancer. The original request needs to be forwarded through without any tampering, or at least tampering only so you can forward it. But like the original request should look exactly like the request that was sent from the beginning, even if it was forwarded through a load balancer. Okay, the client should not um, have any kind of downtime or have any realization that its request has been tampered by the server when it forwarded. It has no idea of any of this that's going on. Cacheable, so data the server sends states whether or not data is cacheable, like cookies, tokens, um, stuff like that. So that's the cacheable layer that we're talking about. You can, as a server, you could actually tell the browser or whoever is requesting, hey, this resource is going to be valid for X amount of days or hours or minutes or seconds, right? So the server can tell whoever is requesting to keep that information, right, for whatever amount of time. So that's what we mean by cacheable. So the next time you try and do that request, it'll actually pull it from cache instead of doing the full request. This allows things to be more responsive on the client side. And you as the server admin, you have to pay less because if you're using a cloud service like AWS or Azure, you're paying for everything. Nothing is free, right? You got to pay for everything: the bandwidth you use, the CPU time, the data that's being read from a database. You got to pay for all of that, you know. And if if this thing is scaled, it's not cheap. It's expensive. So if the data is cacheable, we need to have versions. Oh, what version is this? What's the expiration time? Sometimes we call that the expiry, right? So we need to have all these you know, headers set or whatever, to let you know, hey, this resource is version blah, and by the way, it's going to live for, you know, 30 days or something like that. You know, again, it's very vague because it's on a case-to-case basis, right? Depends on the resources that you're serving. And then we have code on demand, which again, this is very heavy. You know, the reason why it's in parentheses and say it's optional is because your RESTful API could serve web pages. And if it serves web pages, one technique that you can do is, in order to make your web page more responsive, so very, very fast, so load times are like, you know, blink of an eye, is that you only serve the JavaScript, the HTML, and the CSS that is required for the client to just see that one page. So when we talk about React, for example, React is basically like it's a web app, right? So there's a lot of JavaScript involved, and so one technique that people do with React is they do something called code splitting. So when you do a request through a React application, only the React stuff that is required to show you that one page will be sent, and then as you do more requests, as you're navigating through the web app, all those other components, all that other JavaScript and CSS will get pulled through dynamically. So this allows the response time to be a lot faster. Okay, and that's the technique that we call is code splitting. And yeah, this is just code that can be executed by the client. So like JavaScript, HTML, CSS, you know, those are all things that can be executed. But it doesn't have to just be that. You know, you could technically stream through binary data, and I don't know how complicated that would be, but you technically could do that and then like execute it on your computer. Well, I'm not sure how safe that is. But I mean, if you ever run into a problem where you have a satellite, you need to, you know, send code dynamically because the payloads are too small, that is an option. Though, I mean, I don't work on satellites or anything like that, but I imagine something like that is possible. Okay, so we're talking about the web and stuff, and I brought up XML. So one of the things that we need to talk about is something called SOAP. Okay, so again, this is another interview question that you will be asked. What's SOAP? What's the difference between SOAP and, you know, REST? Okay, so if you click on this, there's a beautiful article here, right, on Wikipedia that actually does it pretty good justice. Again, SOAP has been around for a really, really long time. So, you know, I would highly recommend this link just to read for your own, you know, knowledge. Go ahead and read through that. And well, we'll talk about here, okay? So what is SOAP? Again, this is an interview question, okay? I guarantee you 100%, I'm willing to put money. They will ask you this question at some point. They'll be like, hey, what's SOAP? And you respond with, oh, SOAP stands for Simple Object Access Protocol. That's what SOAP stands for. Okay, it's an acronym. What is it? It's a messaging protocol for a web service protocol stack. Maybe it's a transport protocol. Maybe, you know, you have a service like a transport protocol. Then you have the messaging protocol. That's where the XML lies. And then you have a description protocol. And then you have a discovery protocol. These are all things that we call services. Okay. The XML is going to lie somewhere over here in the messaging stack. Okay. So this is super heavy in Java backend servers. Like if you ever heard of like JS servlet, JavaScript servlet, SOAP is used heavy in those kinds of applications. Even like Microsoft backend systems using like ASP.NET, a lot of that stuff is still using XML. So SOAP is still around. So again, depending on which company you want to work for or what company you're prospecting to work for, you should really look into what kind of backends they work on, or what's their backend stack like, so you can get a familiarity of what type of messaging system, what kind of data they are what kind of data or how they're structuring the data in order to transmit it over the web, for example. Okay, so again, any company that has a Java backend most likely is using SOAP. Microsoft ASP.NET again supports JSON, but if it's like an older application, I'm willing to put my money that it's going to be XML based. Okay, so these are valid technologies for you to still learn, even though JSON is like pretty much taking the world by storm and JavaScript is just dominating everything. Um, these technologies, they still have a place. Okay, there's things that SOAP can do that Java the JSON cannot do. Okay, so it's good to learn both. So one of the cool things about SOAP is that you have extensibility. You have what we mean by extensibility is that when we're talking about XML doesn't have like really a standard, like, oh, the data has to be like this. That's not really what XML does. XML just structures how your data looks, but you can define, what that structure is. You create the scaffold. The only thing XML provides you is with like a basic, framework for how you can use tags to lay out your data. Things that it supports are like attributes, for example, okay, that can give extra metadata for the data, okay? But what those attributes are, what they are called, is completely unbeknownst to XML. It just provides you with that kind of that kind of functionality, but the XML doesn't care about it. And I'll show you what I mean by that. And and it has neutrality. What we mean by neutrality is that you can use this in any language. You can use it in PHP, you can use it in JavaScript, C#, C, C++. It doesn't matter what language. Insert any language, XML can be supported by that language. It doesn't matter. And it's independent. This is just data. Okay, this is just data. So it's independent of anything else. We're just structuring the data, so when we transport it, whoever's receiving it knows how to read it. It knows what the data means. Okay, so let's take a look. Here's an example of an XML page right here on this right side. Now you'll notice that this looks very much like HTML, and that's not a coincidence. Okay, HTML stands for Hypertext Markup Language. What does XML stand for? XML stands for Extensible Markup Language. So it's just a way that you can, structure your data. That's it. It's a markup language, and it's extensible. And what we mean by extensible is that there are some built-in tags that have specific meaning, like these XML tags and version attributes. Those have very specific meaning. But the doc, like this tag that we see here, doc, we call these elements or tags. This doc tag or doc element is unique to this application. This has nothing to do with XML. This is just like, you can call this banana, tuna. They're giving it specific names because when they read this information, these nodes will have specific meaning to whoever's reading it. But as far as XML is concerned, it doesn't care, right? These are all custom stuff. Look at these attributes. We have member, name, and it's a string. Again, this attribute, nothing to do with XML. All XML does is it supports things like attributes. That's it. You cannot do this with JSON. There are probably ways that you can try to do something like this, but at the end of the day, if your data needs metadata, XML might be the way to go. So if we click on this link, you're going to go through this W3 Schools tutorial, and it kind of talks about XML. And it's a beautiful place that if you want to learn more about XML, you can go through it. It has some really cool interactive tutorials that you can do. And it's really, really nice. There's even a quiz stuff that you can do, like these quizzes. It's really cool. I love W3 Schools. You can go in here and you can start like a little quiz and just see how much you really know. Okay, so it's a really good way to study. So XML is just designed to store and transport data. That's it. That's all it is. And it's designed to be self-descriptive. So when we look at this, this is doc. Okay, so we must be talking about a document. Assembly. Okay. Well, if you've done any programming, especially with like, you know, anything that has to do with like, Microsoft like stuff like, .NET, then you know what an assembly is. Okay. So assembly is just like, kind of like the environment in which your code kind of lives. You can have multiple assemblies. Um, so in this assembly is just plugin.share. Right? That's the name. So assembly has a child. Again, this looks very much uh, HTML. We have these nodes, okay? And nodes can have nodes. They can have children. So it's very, very cool. So we have members. Now notice how it's plural, and then you have a member. So members here, we can assume that members is, because it's plural, there will be multiple members, right? And look at here, we have a member, we have a member, we have multiple members, and they all are on the same uh what do you call this? Depth. These are all siblings, right? These members are right next to each other. So we say these members are siblings of one another. And they're all the children of members. So members has these children. And this particular member has a child called summary. So summary has a parent called member, and summary also has a grandparent called members. And as you can see in this member has an attribute called name, and it doesn't matter what that is. And then summary has some data. So in this particular member, the summary is cross-platform share implementation. So it's just a string. Cool. And then in this one, it's gets if the plugin is supported on the current platform. And notice that this member has a name. It is p::plugin.share.cross-platform.is supported. This looks like a variable. And if you know C#, then you know what this is, right? This is a property. These are properties. So what's really cool about XML is that from XML, if you use the attributes correctly, and if you understand the power behind XML, you can actually take XML and then dynamically create code from it, like recreate the code. It's actually pretty dope. Okay, so that's something that XML can do. And again, as I'm talking about this, I'm looking at this, you can see that it's designed to be self-descriptive. I can look at this and I can kind of understand what's going on. Again, I didn't write this, but just looking at it, I can start to kind of understand what this is. And that's kind of the point of XML. XML in Java and JSON is supposed to be human readable, right? You're supposed to be open up. You should be able to open up this file, and as a human, you should be able to read it. If we cared about space, then we would not use XML or JSON. We would use just straight binary blobs and send that over, right? 'Cause it's super compressed, super tight, and we can't read it, so but it wouldn't matter, right? It's not human readable. So we can see here that XML is designed to carry data. So the data here is this gets if plugin is supported. So all these tags here, this information is between these tags, that's the information, that's the data. Everything around it, the scaffold, is just what's used to carry that data. That's it. That's all it is. And HTML is designed to display the data. That's where HTML comes into play. So when you have your tags, those HTML tags, XML is designed to carry the data. In HTML, when you have those very specific design tags like label, div, whatever, those tags have specific meaning of how to display that data. So you can see there's the contrast between the two. So if you're trying to get an interview at a company and they ask you, hey, what's the difference between XML and HTML? Because they have very similar syntax. Can you tell me the difference between the two? You can be like, sure. The main difference between XML and HTML is that XML is designed to structure and carry data, versus HTML is designed to structure and display your data. And boom, you'll get the interview, right? And if it's an interview question, hopefully you move on to the next round, right? It's very simple what these things are. It's not overly complicated. It's very simple. Okay, cool. And so now we're going to get into the routing phase. So now that we've talked about that, XML, I just wanted to talk about it because I want you to know that it exists. You might run into it somewhere in the wild. So I just want you to be informed, be an informed developer. So I'm letting you know that there's these other data transport systems that we could use, like XML, right? That's totally valid. It may be overkill for application, but in certain situations, it makes sense to actually use it, okay? So I just want to show you that those kinds of technologies exist, and for your own knowledge and for your own sake, you should look into them. You should learn how to, read it. You should learn how to work with it, okay? For the remainder of this entire course, though, we will be focused on JSON. But again, if you have any questions about XML or anything like that, feel free to ask. I know XML pretty well. I use it a lot, so you can by all means ask questions. But most of it is going to be on a case-by-case basis, right? It really depends on the application and how it's going to be consumed. Okay, so yeah, that in mind, let's move on to routing. That's the topic for today, is routing. Okay, cool. So we'll spend the next minute or so, and let's do this little pop quiz. So feel free to answer it in the chat, or if you have a piece of paper, to see if you've been paying attention this entire time. Try to answer these questions. So number 1, what does HTTP stand for? That's a really good question. Number 2, what architecture is HTTP? Number 3, what is TCP? Okay. 4, name 2 headers in a request. And then finally, name 1 response header that is not in a request. Okay, so try to answer that in the chat, all right, or answer in the Discord. That's also valid. Okay, so let's see how many of you guys have been paying attention. Let's see how many of you guys can answer. Okay, so I'll stick here for a minute or so, and yeah, see how many of you guys can answer. So feel free to talk amongst yourselves in the chat. Yeah, this would be very great if we could do this in person. Split up into groups, talk about it, come up with some answers, and but hey, COVID, whatever. So we have one answer from Victoria. Anybody else? We got another answer from 3D, architecture's client server. Okay. The next slide will have the answer, so just put in whatever you think it is. Don't be afraid. It's okay if you're wrong. Just put whatever you think. Don't be afraid. Take the jump. Come on. So thank you for Victoria and 3D for participating. Anybody else? Give it an extra 30 seconds. Alex participating. TCP, he says, is transfer control protocol. Okay. 3D asking, is TCP transfer control protocol? Well, we'll see on the next slide. So anybody else want to answer any of the other ones? What about the headers? Nobody knows the headers? Come on, guys. You guys need to know the headers. That's very important if you want to do back-end design. You need to know some of these headers. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right. Pencils down, quote unquote. All right. So, what does HTTP stand for? Hypertext Transfer Protocol. Okay, so Victoria, good job. There you go. What architecture is HTTP? It's client server. So good one, 3D. Perfect. What is TCP? TCP stands for transport. It's a transport layer in which bilateral. Did I ask what is TCP or yeah? I think I asked what is TCP. Did I ask what is TCP? Okay. Yeah, what is TCP? So TCP is a transport layer, right? So it's a transport layer. So in which bilateral communication can be achieved. And yeah, it is transfer control protocol. That's what TCP stands for. And then name two headers and a request. So a typical request could have like content type that tells you, you know, what, let's say if you're the client and you're going to send some JSON, the content type would be application slash JSON. Again, we're going to talk about that, but you want to tell the server how it should interpret the data that you're sending in the payload. Okay. There's also another one called application type. Those are two that are part of a request. And some response headers that are unique only to the server and not the request is server. That's a tag that you as the server could add to your response, though I don't recommend it, but you could do that. And the other one is the date. It's the time in which the server actually got your request and was able to serve it. Okay. Cool. So let's set up our code again. So this is we call this boilerplate code, right? This is the code that we at least need minimal in order to get running. So let's set up our project here, and I have basically all the code. So I have the module. So again, this is the module from Node, the HTTP module. We're going to create the port. Again, there should be a double pipe, not a single pipe there. If you want to do it this way. We'll talk about environment variables, but for now, you could just ignore this. Just set it to 3000. We're creating a server object from the HTTP module calling .create server. And again, you feed it a lambda. Remember, this is an arrow function who takes in two parameters, request and response. Okay, and again, this is just empty. So I will make it just like that. So I will remove this hello world stuff that we had. And then you need to tell a server, hey, I need you to listen on this particular port. And then you feed it a arrow function that's a callback that'll let you know when the server's up and running. And you can say whatever, but we usually just say listening on port, and then you just specify the port. And that's fine. Okay, there we go. Beautiful. Now, so you guys, again, you guys watching out there, hey, use Postman to send a GET request, then display the URL from the request on the console, or send the URL back to the client in a response. So this is going to require you, okay, to start to inspect either Google, right, you reading the Node documentation, or just inspect. Look at what I'm asking. I want you to display the URL from the request. So notice I'm saying from the request. Where's our request object? Look, it's this one. So when you inspect a request or any kind of object, really use the dot operator. So you say dot, okay, and then you get a bunch of stuff. So the idea is, I don't want to show you, but I want you on your own VS Code, I want you to go in here and I want you to find what I'm asking for, okay? So you got 2 minutes. Okay. I am opening up Postman. 2 minutes are up. Should have taken you 2 minutes to do this. All right. So my server's running on 3000. So I'm going to use Postman. I'm going to hit send. I should get back the URL in which the request came in. Okay, and I did. I get this /, right? Interesting. /. Very interesting. So what happens if I were to do a /? What happens? I get a /. So if it's not there, or if it is there, then you're always going to get a /. So that's interesting, right? So this actually is a way for you to know what's home. What is home? Home is just /. Okay. What if I did something else? What if I did something like media? So I did blah 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 /media and I hit send. Interesting. Interesting. Right? What if I do something else? I do /photos. Interesting. Right? Are you guys seeing this pattern? Do you guys see how we can use this to create routes? I hope you do. Okay. Move this out of the way. All right. Let's keep going through the slides. Okay, so the URL object or property. So the URL from a request does not include the domain. You must handle all corner cases, right? If we're working with HTTP server directly like this, okay? And some advice is look out for potential 400 bad requests and 404 resources not found requests. Okay, again, I'm trying to get you into the mood of understanding resources and these paths, these URL paths. Okay, and this is the code that is required in order to achieve what I did. So in this case, we're just going to log to the console. But the way I wrote my code here, so I'll blow this up. Oh, that's too much. Let's back it up a bit. I use write. So I say, hey, let's get the response object. I'm going to write to it the request.url. So I'm going to respond back to whoever's requesting this. I'm going to respond to them with the URL that they did the request on. And then remember, you have to say response.end in order to cut the communication. So everything that you wrote in your buffer gets flushed. You don't call end, the client is always going to be waiting. Okay? And the result was exactly what we saw, right? Every time we did a request, the server automatically responded with the URL that we did the request on. See? When we don't have anything, and you just have the port, whatever, you hit, and you always get a /. That's the default. Okay, that's home. That's home. / whatever is any other URL. So I could say, you know, banana. Okay, hopefully I spelled that correctly. Now you get /banana. Again, this is all made up at this point. It all depends on what kind of resources you're going to be sharing and how you want to structure it. So this is what I mean by, at this point, this is all made up. There is no standard here. There are some suggestions, like you should only use nouns, and you should use plurals when you're trying to indicate that you're going to get more than one of that thing. Okay? So the only kind of like suggestion that we have for these kinds of things is that always use nouns, like banana. Don't use verbs. The reason why you shouldn't use verbs is because that's what the HTTP verbs are for. Getting something, posting something. That's like, you know what I mean? Like you wouldn't want to say banana /create. That doesn't make sense, because here I say I want to create a resource, but then if I use a get request, that indicates I want to get. What are you getting? You're getting the creation of a banana. That, you see, like we're falling into this very weird grammatical, you know, bad thing. Okay, do not use verbs in your resources. Don't use verbs like create or whatever, or delete. Don't do that. That's what these HTTP verbs are for. If you want to delete something, send a request via a delete command, via a delete verb. Don't put delete in your URI. Just say banana. Now, this makes sense. Look, we sent a request. to delete the banana. That makes sense, right? It makes grammatical sense and just makes logical sense. We want to delete the banana. What if you had multiple bananas? So you had multiple bananas. Well, you probably don't want to delete all the bananas, but what if the bananas had an ID? We could say delete banana with ID 1. Delete the banana with ID whatever. Oh, so in all the bananas, delete the banana with this ID. If I switch this to users, now this starts to make more sense. Delete the user with this associated ID. Oh, look at that. Starting to make a little sense. Okay, so you want to recap? Sure. So here, we're bringing in the node module. Oh, Jim asked or says, I'm a little confused what write is doing on the server. Yes. So if we hover over here, oh, it doesn't tell you. So what write does is think. I don't know if you've ever worked with stream objects in like Java or C# or in C++, but let's think about let's use a picture. I'm a visual person. Okay, let's use pictures. So we have this person A. We'll call this the client, and then we have the server S. So that's our server. Okay. We have this request. Okay, this request. We say something like get slash we'll say Apple. Okay, because again, these things are completely like arbitrary. So we say get slash Apple. So we send that request over to the server. Bloop. Okay. Now what happens again, there's a lot of things that happen here, like the handshake and all that other stuff, but let's just ignore all that. If you want to learn more about that, go to the slides. After the TLS whatever handshake happens and we establish communication over TCP, let's say, okay, now we send the request. Can I get the banana? Server's like, okay. At this point, the client now starts to wait. We have a spinner. It's waiting until the server responds. It's possible that the information that you want is quite large. Okay, so the way it works is your response container, so the response, we say the response object, has a bucket. We have a bucket here. This is called your buffer. It's empty in the beginning. It's empty. If you want to fill this, like, oh, you want the apple, the server needs to like go to the garden. So we got to go to the garden, whatever this is, and there's all these little apples, right? This is an apple tree. Okay, don't make fun of my drawings. I'm doing this with the mouse. Okay, there's an apple tree. So the server has to go out to the apple tree, pick the apple, and then come in and then be like, hey, I want to put this into the response because they wanted the apple. Here's an apple. So the way I do this is I say respond dot write. Okay, I gotta write the apple, and then this is your data, whatever it is you're gonna put in here. In this case, I want to put the apple into this buffer. So like, there's the apple. Okay. Oh, that's a cherry. Hold on. That's an apple. What happens if we take a bite out of it, right? Is that more like an apple? Is that copyright infringement if I do that? Okay, it's a bitten apple. Okay, hopefully Apple don't sue me. Okay, so there we have it. Now we have it in our buffer. But the client doesn't have the apple. It's still waiting. Because what if what if the server wants to put more information into those little basket, a little buffer, right? We can write more. We can say response.write something else. Let's say for good measure, we also send it, I don't know. I don't know. Maybe send it some money too. Send it some money too. There's a money. Okay. You can write more stuff. So you can continuously fill up this buffer as much information as you want. You can put a whole file. You can put a whole video file in there. You can put your entire, operating system in here. You do whatever you want. Put whatever. This buffer just keeps getting bigger and bigger and bigger. Once you say response.end, Okay, basically, hey, I'm done writing to this buffer. I'm done. Once this happens, then, a package is created. This is what we call the response. The package is created, and there's the apple. I keep making a cherry. Whatever, it doesn't matter. There's that money. This is the payload. We call this the payload. This is the payload. Okay, the payload. Then this finally gets sent to the client, and then the client is happy. This situation right here could have taken 5 years, say, and the client would be waiting for those 5 years. And then once you call end, it sends it over. Okay, so writing, when you say write, we're just filling this buffer, the information that when we call end is going to be part of the HTTP body. So again, you can put anything in there. You can put a file in there. You can put the entire text of the Harry Potter in there, a PDF, a video, an image. It doesn't matter. You can put whatever you want in there. Writes is just the method that we use in order to put data in there. Okay, that's it. That's it. We're just filling up this buffer, this bucket of data. That's it. That's all we're doing. That's what write does. You can do a lot with it. Okay, so you can see how powerful this can actually become. Okay, hopefully that answers your question. What write's doing? Okay. We got a Picasso training over here. Yeah, drawings are so good that no one can make fun of them. Thank you. Thank you. I try. Okay. I like to use pictures because it helps me. Hopefully that answers the question. And yeah, that's what write's basically doing. Now, what is URL? URL is a string. Write takes in that. Sure, right. It could take anything. Right? Just stick it in there. Doesn't matter. Right? Heck, there's the URL. I'm gonna do something crazy. I'm gonna say write. I'm gonna give it. Like I have to. It's a good idea to feed it as a string or a buffer, but I can stringify a JSON object and say name, Bob. I'll put Dylan in here. Again, I'm doing this to show you that you can stick anything in here. Age. How old is he? Maybe like 70, something like that. Okay, I gotta kill the server now. So originally I was just putting the URL, but now I'm going to also write into the buffer this JSON, right? This is a JavaScript object. I'm going to stringify and make it into a string, and I'm going to put that into my bucket too. I want to send that over as well. Okay, so now when I go over here and I have my URL here, whatever, I hit send. I get the URL, and then I also get this. Look at that! I got this other thing. This whole thing came into the payload with it because I wrote it into my buffer, and then this came with it. See? So you can write a bunch of stuff. You can write a bunch of stuff, right? Doesn't matter. Just write whatever you want. So that's what write does. It just puts it into the buffer, and then when you call end, it flushes it, creates the whole HTTP response, puts it into the body, sends it over. And remember, TCP, HTTP, whatever. If the file is gigantic, like it's a 4K video and it's like 50 gigs, that's possible, right? You want to send that over. It will fragment it. The packets will get fragmented. You don't take care of that. It will take care of it. So don't even trip. Right. Very good. Very good. So hopefully that makes sense. All right, cool. So again, here with Postman, we're doing the same thing. We're gonna do this, ID slash data. Again, it's arbitrary. Do whatever you want. In this exercise, what we're trying to show is that whatever is after the domain, this is the URL part that we're talking about. So the HTTP request object has that information. It has that information. So let's look at an example of that. So in Postman, like I said, Postman is incredibly powerful. Okay, because here, let's say users. Let's say, for example, right? For example, let's say I wanted to get all the users, right? Because that's what the GET request is basically means. That's the verb. It's the action, right? Get. I want to receive stuff. What do you want? The resource I want is this slash users. I want the users. See, this makes sense, right? If you just think about it, you have the verb, which is your action, get. What's the resource you want? Users. So I expect to have more than one. However, when we say in our request, we need to give the server all the information that it needs. Let's say, for example, I want all the users, but I want to sort them. I want to sort them. So how can I do this? You could do this through the URL, through the request resource here, by adding what we call query parameters. Okay, so in Postman, it's very easy. If you don't have to do it yourself manually here, you can just, in Postman, click right here. All right, I have the users. Let's say I have a sort. I want to say sort. I want to say sort, ascending, ASC. Sort ascending. What else? Maybe we want to do some pagination. So we say limit. So I want to have at most 10 10 results max, right? Because I'm assuming I will have an array. So we can start pagination, right? We can do something like that, right? So here the users sorted, ascending, and I only want 10 at a time. Well, there you go, right? You can make it more, a little bit more specific. Give more information to the server on how to send you the data, right? And then let's say, for example, that this API required you to be a developer with them. So you needed a special key. Well, we could put that key in here. You call this an API key. An example of this was what? Open weather map. And then the key probably looked something funky like that. And that's your API key, whatever. Okay, cool. So when I send this request over, I hit send. My server got it. The request URL was slash users, and then the question mark indicates that it's the beginning of the query parameters. So here I have sort equals ascend, and then the next query parameter is appended using an ampersand. Beautiful. And it's just key value pairs. You put the key, what the query parameter key is, equals, and then the value could be anything, right? Well, not really anything. It's like usually like characters, right? You don't put a file in there, just characters. Although technically you could do URL encoding, but we're not talking about that. All right, that's really it. And so we have all this information, so we can actually parse this out, so we can actually do the response with the following query parameters associated with it. For example, let's say we pull the user from a database. In our query, we could say, hey, I need you to sort it ascending order. By the way, only give me 10. Beautiful. Now the query, the backend for our database, for example, like SQL, MySQL or whatever, can do all this stuff. So we can feed that over to the SQL query to be like, hey, sort it ascending and limit 10. Boom, done. Right? And again, the client has no idea that you're getting it from a database, right? He has no idea. Then that's kind of the point. See, the client is agnostic to what the backend actually looks like. We're just communicating over with a URL, this URI URL. That's it. The client has absolutely no idea how this data is going to get found. It's just asking for it. See? It's agnostic. Cool. So again, going over Postman, the HTTP verb to send data to the server. So here we have post. In this example, we're using post. And with post usually means we're going to send data to the server. Something. Let's say we want to send it a file, or we want to send it information about how to create a user, like your first name, last name, email address, stuff like that. So there are ways to do that. One way is through the form data. So that's a form data encoding. That's part of the headers. There's this other thing called XWWW form data. It's another type of encoding. Or you could do it using tuples, right? Which is just the query parameters, just key value pairs. Okay. Now, at this point right now, we've just been sending just an arbitrary URL, but when we say when we on the request object, when we on further inspection, you will realize that this is just a string. How could I get this query parameters separately if it is that they do exist? Remember, you can send a request without query parameters. It's possible. So how can we get more information, right? How can we parse this data out? Well, you're in luck. There is a module built into Node.js because this is a task that has to be performed by anybody that's using web stuff. So it's pretty common. So Node.js has a built-in module called URL. Okay, and basically it splits up the URL into readable parts. Okay, and so you just bring in the module here. So const URL equals require URL. Cool. And then all you have to do is feed. There's a method on URL called parse. So there's this function. All you have to do is pass it the string that you want to parse out, and then query parameters set to true. And then there's this object. You can call it whatever. I called it path. That's a terrible name. You probably just call it URL or something like that. Parsed URL, probably a better name. And then here I'm just gonna log out. And then this is what it looks like. It's a JavaScript object, and it has a bunch of properties. Look at the properties that we have here. Here is a property called search. This is going to give you the original. This is just like the query parameters, right? Just the query parameters. Then we have something called path name. Path name is the path slash data, just the path without the query parameters. So this gives you the ability to route things to other places, right? Different destinations. And then we have this other thing called a query. Query is a object. And you'll notice that the query parameters that we see here have now just become a JavaScript object, with the keys being the keys of the query parameters. See, we have name here, name pops up here. And then the value of the JavaScript object in this tuple is just whatever you set it equal to. So this is Kevin. This %20, we'll talk about that, but here it says Kevin Pacheco, that's my name, and you'll notice, boom, it's right there. Age, 26. Wow, that was 2 years ago. I turned 28 yesterday, so wow, that was 2 years ago. Jesus. Major, I put computer science, and there you go, right? So this gives us way more flexibility. So now, if somebody was asking, hey, can I get the users? Well, before you send it off to SQL to be like, hey, can I get the users? If they want to be like, hey, can you sort it ascending or descending? You could actually check to see if any of those options are set. And if those options are set, respect them. Else, do some default thing like, oh, the results will be assorted by descending by default or whatever, right? We're going to do a demo here. All right. So let's do a quick demo here, and let's talk about it. All right, let's see it in action. Oh, thank you for the birthday wishes. Thank you. So let's bring in this module. So const URL equals require URL. Boom, done. Easy, simple. Okay. Now I'm gonna delete this right here. Delete all this. I'm not gonna send anything back. Instead, I just want to print to the screen, the individual parts, right? Look, this is pretty complicated, right? It'd be, you could parse this out yourself, but you would have to write that yourself. Instead, we can use this module that'll parse this stuff out for us so we can get the parts individually. So I'm gonna call this variable whatever. I'm gonna call it Apple just to make it clear you can call this whatever. It's just a variable. So here's the important part. You say URL, which is our module, dot, okay? And then we say parse. Oh, this is interesting. So use the URL API. Interesting. Okay, so this is deprecated for some reason. Let's see what the heck they're talking about here. Oh, is this a package? Is a full implementation of where else time? Okay. So Node is basically saying, don't use our module, use this module. Okay. Look how popular this is. Like, this is what? Weekly downloads. Almost 16 million weekly downloads. So there's a lot of back-end developers that are using this shit. So I'm just saying. I'm just saying. All right, so let's do what Node said. Just use this. Hey, but this gives us a chance to talk about how do we add external modules, external dependencies, right? How do we do that? So this is actually a good segue to that. So the way you do that, so to add dependencies from the outside world, like this new dependency that we're going to add, you have to set up your project to accept dependencies. So the way you do that is by executing the following command in your command line. npm init, okay? When you do that, it's going to ask you a series of questions like, hey, what's the package name? So usually the package name is supposed to be like, you know, whatever your module is supposed to be called. So in this case, I'm just call it like, you know, SoDA node, whatever, doesn't matter. Version 1, sure. Description, this is to show an example of HTTP backend server for APIs. Okay, cool. Entry point, sure. Custom command, we'll leave that blank. Get repository, leave that blank. Keyword, blank. Author, yeah, we can leave that blank. License, MIT. Is this okay? Yes. Done. Then you get this package.json, which has all that information. Okay? If you're lazy like me and sometimes you're just trying to get something quick and dirty, okay, so remove package.json. Your other option is just to run npm init, same thing, but instead you do -y to basically say yes to all the defaults. Boom. And then you'll see that things are now different. The name is going to be the folder name, and then you have all these default stuff. Cool. Now that we have that, we can execute these commands. Like npm I stands for Node Package Manager install, and then this is the package. This is the module that we're going to install. And I got that command from here. They tell you how to install. You literally just click here. It'll copy to your clipboard, and then that's it. And then you can read, you know, how this works. I've not used this before. I didn't know the other thing was deprecated. So let's read this together. So where is the GitHub? Here's the README. All right, how the heck do you use this thing? Where are the examples at? Cool. So I just want to know how to do this. That URL will be the result of running basic personal website. Okay. Let's see if this is not that complicated to work with. Okay, so let's try and use this new thing. We'll call it URL still, and then we'll bring it in. So now that we have that thing, it's called W something. This one. Okay, let's see how this works. We're gonna do it live. So URL dot and oh, look at that, parse URL. That's easy. Parse URL. Input string request dot URL, and there's these options here. So what are the options that we can do? Okay, we don't need any of those options. Cool. I've not worked with this before, so perfect. Let's log this to the console and see what's the shape. Okay, so here we're bringing this new package that Node is actually saying that we should use instead of using the other built-in one. They're saying it's deprecated now, so you should use this. Now that we have this, it looks very similar to what we have the old code. You say parse in this example, but here now we say parse URL, not too bad. And you just pass in the string. And this is, I'm assuming, should create there's this URL record. It should be a JavaScript object. So we're just going to print it to the console and let's see what it looks like. So I'm going to say node app.js, run that. And then here in Postman, I've created this funky looking URL. So I'm gonna hit send. Oh, do I hit end? Yes, okay. I'm gonna hit send and let's see what my server responds with. Oh, and we get null. Ooh, that's not good. Ooh. Okay. I don't know how this works. They changed it on me. Parse basic. It's not expecting to be doing this today. Set the URL. Okay. So many standards. Okay. A nice example would have been nice. Okay. Let's try the other one. Dot basic URL parse. URL base. Why does it want so much information? Okay. Sorry, folks. I've not used this before, so I honestly don't know how this works. I keep getting null. Okay. So thought that was going to be parsing that. Okay, this doesn't make any sense. Base URL. Interesting. Okay, so maybe I stick the URL in here. So that's kind of weird if that's the case. Okay, yeah, I don't know how this works. And this entire thing is null. Is this a promise? No, okay. All right. Let's use the old deprecated so I can just show you what it looks like. We'll use the old deprecated way. So we'll say parse, though it is deprecated, so I might throw an error. I'm not entirely sure. And the second option is parse query parameters. We're going to set this to true because we do have query parameters. And let's just look at what the old way. I'll figure out how to do the new way so I can show you. The old way looks like this, which is exactly what we're looking for. It's simple enough. It's not complicated. This new way looks complicated. I don't know why. All right. So here, if we look at our URL, the URL here, the path name is just users, and then the question mark begins the query parameters. So one of the query parameters is sort, the other one is limit, and then API key. Okay. So what's really cool about this is that the search criteria or all the query parameters are going to be placed in this property here. So you see you have the question mark, and then so you can see what it looked like. But what's really cool is that what the parse is going to do is create a query property that's just a JavaScript object that has all of your query parameters as key value pairs. This is really nice because then you can use basic checks to see if a particular query parameter exists, and then you can do stuff like fallbacks. Like if they didn't specify how to sort, how should we sort the data? Oh, by default we'll use ascending, for example. You can do stuff like that. And then if you want to know what was the resource they were looking for, that's under path name, right? Where is it at? Over here. Trying to parse this out yourself is going to be a nightmare, right? So don't do it. Use a module. Node is saying you should use that other module, but I couldn't get it to work, so I'll have to see what I'm doing wrong. I'm sure I'm doing something wrong. But anyways, by using a module like URL, we can parse this stuff out for us, right? So now look at that, it's beautiful. We have the path name, so we know what the resource that we're looking for, and then the query parameters is basically telling us extra information or extra ways for the data to be handled. For example, sorting. What should be the limits in the response? Only 10 records, for example, and then any information that identifies us. So this API key will identify who we are and also give us authority that we can actually do this request. Again, this is all hypothetical stuff, but this is basically what you're going to be working with 99% of the time. Okay. And then here we have a demo. Let's see how much time do we have? All right, we're out of time. However, I will leave this as a quote unquote homework assignment. Okay, so here it is. Create a post route that takes in a person's name, ID, and major as query parameters. So to see an example of what this looked like, it's here, okay? And to see what it looked like, it's right here. So your postman should look something like this, okay? So use those slides. And then construct a JSON object and send it back as JSON, not plain text, okay? So you might not know how to do this, but if you look at the hint over here, right, we have this information right here. Okay, so it says recall. Okay, I feel like I'm missing some slides. Like some slides I think I deleted. Well, let's go over that real quick right now. So let's suppose that something here went wrong. Right now, the default is a 200, okay, everything's good. But let's say, for example, I don't know, sort is not a valid query parameter. I don't know. Let's just say something like that. And so we want to change the status code. Remember, these are the status codes, right? So right now we're responding with 200. So let's change that. So we can say response dot oops. The status code, okay? If you hover over status code, it's just a number. So we're going to set it, and let's just say it's a 400. So let's see what happens when we set this to a 400. We're going to run this again, and then postman, I'm going to hit send and observe here. Now it's a 400 bad request, okay? Boom. So that's how we can change the status code. So this right here allows us to change the status code. So 400 means bad request, for example. Okay, what else? Yeah, so here's some like super popular ones. 200, everything went okay. 400, bad request. 404, resource not found. Okay. Now, if I send data back, since we're going to be working with JSON, remember, you have to set the headers. You need to set the headers. That way, the client knows what the data is, how the data is supposed to be interpreted. Is it just text? Is it HTML? Is it CSS? What is it? So let's show an example of me writing. Or let's do it like this. Let's create an object here. I'm gonna call this person. And this person object, again, this is just a plain old JavaScript object. Let's have a F name be Bob, L name Dylan, and then genre American folk. Okay, so let's say we have this person and we want to send this back, for example. So again, the way we do this is we have to write. So we say response.write. Okay, and I need to convert the JavaScript object to a string. So I say JSON.stringify. Okay, and then I pass in the person object. Okay, because it's a JavaScript object. So this is going to convert it into a string, and I'm going to write that, and then I'm going to end. That's it. So I'm going to kill the server, restart it. So all I'm doing here is just pretend that this object was in MongoDB. Okay, let's just say, for example, this was in MongoDB. Okay. We know it's JavaScript, JSON, right? We know it's JSON. Okay, but Postman's not going to know unless we tell it. So if I hit send, okay. Oh, am I running it? I didn't run it. Oops. Hit send again. There you go. Now notice that Postman, if you don't specify a header for the content type, it's just going to treat it like plain old text. When in reality, this is actually JSON, correct? This is JSON. So we need to set the headers. We need to tell it, hey, by the way, the data I'm going to send you, it's JSON. Okay, how do we do that? So we do that in the response. We say response dot set header, and the header is here is just a name. What's the header name? Content dash type. Okay, it can be all lowercase, or you can capitalize it. Doesn't matter, as long as it says content type. And then the string, like the value, what is it? Content type what? For JSON, it's application / JSON. If you wanted to send XML, or if you wanted the client to interpret your data as XML, for example, you would say application / XML. But in this case, we're using JSON. Okay, so remember, when we didn't send the content type, the client here, in this case, Postman, interpreted the data as what? Text. Okay, so let's kill the server, save, run it again. Postman, we're going to run the same thing, hit send. Now look at the difference. Now Postman knows that, hey, we sent, oh, the data, I should interpret it as JSON. Okay, look at the headers now. We have a content type. Before this wasn't set, look at it now says application / JSON. Beautiful, beautiful. Very good. See, now it's all formatted, all pretty. Okay. So with that quick and dirty demo of that, you should be able to do this on your own. Okay. The JavaScript stuff we've already talked about. You should be able to handle this part. If you have any questions, feel free to ask in the Discord chat. But I leave this as an exercise for you guys. So on Friday we can go over it, and we'll talk more about. So today we talked about routes, what they are, but on Friday we're going to start building our own routes. So yeah. Oh yes. We may not be able to do that. Okay, never mind. We're gonna have to say this for Friday because you can't do that. Again, I think I'm missing some slides here. But yeah, don't do this because you can't. We'll wait for Friday. All right? We'll wait for Friday. All right. Bye, everyone. See you on Friday. Unless anybody has any questions. Anybody have any questions? Let me know. If not, I will see you guys on Friday. I'll give you a couple minutes to ask your questions. That last 5 minutes was like rapid fire, but I'm pretty sure I'm missing some slides. Something is missing here. But anywho. If anybody has any questions, let me know. If not, I will see you guys on Friday. All right. See you guys on Friday. Bye, everyone.